2 of Algebra 2 semester review. Yesterday, or part 1, we did all of the backside here. It's not filled out on my sheet, but we did 33 and beyond. We're going to start here with chapter 8. I'm going to skip 27 for just a minute because we're going to do all of chapter 8 so we can keep all on the same page. Then we'll go back to 27, then we'll go backwards that way, okay? So let's do all of chapter 8 first, okay? I am going to give you guys the sheet that you will have on. Actually, somebody want to pass these out? Pass them out? Sure. Emily's going to do it. You can take half of them if you want. Okay. They're going to pass out. On the front side of the sheet is the empirical rule. On the back side is a unit circle. This is the paper that you will hold on to and use for your semester test. Okay. We're going to use this today, especially the empirical rule side. But this has everything you need on it. So the packet and this sheet is what you're using on your semester test. Good? Okay, so I'm going to start going. 28, a fast food restaurant gives 25 of their customers a sample of a new milkshake, and employees monitor their reactions as they take it. Is this a sample, observation, or experiment?
Observational.
Observation, I would say. Okay, and why? What's a word or two that I can underline?
Watches.
They are watching.
Watching reactions.
Monitoring their reactions. That is an observation. Monitor reactions. Okay, so observation there is why. Good? 29. In a study of 150 high school students. So we only surveyed 150. My explanation is my underline of monitor reactions. Okay? I'm totally cheating. So 150 students is how many I'm surveying. 78 of them said that they were happy with their class schedule. But there's not 150 students, there's actually 2,000 students. So if I were to survey everybody, how many would that be? How do I figure this out?
49.
How do I figure it out?
78 divided by 150.
Okay, so 78 over 150 is my first fraction. And that corresponds to how many over 2,000? So I can do it as a proportion, right? And then what?
Multiply.
Cross multiply. 78 times 2,000. Equals 150x, divide by 150. So all of that, 78 times 2,000 over 150 is how many? 1040, I think. Is that right?
Yes.
Somebody check. 1040?
Yes.
So if I were to survey all 2,000 students, approximately 1,040 students would say that they are happy with their class schedule. Because according to my survey, that's how many, 78 over 150 was how many did. Yeah? Number 30, the number of tickets sold at a high school basketball game at a particular conference are normally distributed with an average or a mean of 68.7, standard deviation of 13.1. How do we do this?
Draw your bell.
Draw your bell. Here's my bell. What goes in the middle? I'm going to turn this sideways. The mean, 68.7. Okay, that mean goes in the middle, 68.7. Okay, and then we do 3 added and 3 subtracted, right? So if what am I adding each time?
13.1.
13.1. So do it for me. 68.7 plus 13.1.
81.8.
81.8. Okay, and the next one?
94.9.
94.9. Okay, and the last one? Add it again. 108 exactly. Okay, then start subtracting. So start with 68.7 and subtract. Did you guys get all those numbers down? You want me to read them again? You got it? Okay, 68.7 minus 13.1.
55.6.
55.6. Okay, next. Minus again.
42.5.
42.5. Minus again.
29.4.
29.4. Great. Okay, there's those numbers. All right, now I'm going to turn back this way. They want to know the highest 2.5%. Okay, the highest 2.5%. So I'm going to go to my bell curve. You guys each have one of these now. If you didn't already have yours. Okay, the highest 2.5%. This is 2.4% here, and this is 0.1%. So those two added together make 2.5%. All right. The cutoff mark for that 2.5% is everything from here and beyond, right? from here and beyond. This is that +2. That's 2 standard deviations when I've added it, right? This is 1, this is 2, this is 3, this is -1, -2, -3, right? Okay? So, where is the cutoff mark? 94.9 and above. That's the +2 and beyond, okay? Some of you guys, when you did this as homework, did 94.9 to like 108. It's not stopping at 108, it's going on forever, right? That 0.1% is everything that's above this mark. It doesn't cut off up here, okay? It goes on forever beyond that. So you would say 94.9 and above, right? Anything above 94.9 tickets. So if you sold 95 tickets at your basketball game, that's one of the really, really, really big games, because that's like you rarely ever sell. Only 2.5% of the time are you going to sell more than 95 tickets, right? Only 2.5% of the time. All right, another question like that is 31. The number of minutes it takes Phil to commute to work. What does commute mean? Travel, walk, ride in a car, go on a bus, however he's commuting. Okay, here's my bell curve again, and the average is, what did it say? 18.6. So I'm going to put that here. I'm going to put it sideways so I can see. 18.6 goes here. What's the standard deviation?
3.5.
3.5. It tells me that right here. So we're going to add,
22.1.
okay, 22.1. Add it again.
Why are we adding again? Don't we just go down?
25.6.
Well, whatever. 25.6. Next one.
29.1.
29.1. Okay, that's 1, 2, 3. Then we're going to go down, -1, -2, -3.
15.1. 11.6.
15.1, 11.6,
8.1.
8.1. Okay, there's those numbers. Good? All right, now we have +1, +2, +3, -1, -2, -3. Those are like the number of standard deviations we are above and below. They want to know what percent of the time it takes him between 11.6 and 22.1 minutes to walk to work. Okay, so 11.6 is here at what station? -2, and 22.1 is at +1. Okay, so you go to your bell curve. -2 is here, right? This is where it cuts off. And +1, okay? There's 34% here, 34% here, and 13.5% there. So the percentage between these two is those three added together. This right here is 68%, but then I'm adding 13.5 to that, 81.5. So 81.5% of the time, he can expect it to take between 11 and 22 minutes. Does that make sense? That just helps with planning purposes. Most of the time, it's going to take between 11 and 22 minutes to get to work, right? Okay. All right, 32. Am I going too fast?
No.
No? Okay. We're already going to get further than the 6th period class, I feel like. Use the following data to create a box and whisker plot. Be sure to include the 5-number summary. Okay, so in our 5-number summary, what do we need to include?
Your starting number.
Okay.
Biggest number,
Your minimum, your maximum, okay?
Your middle, and then your two.
Your middle, which is called your median, right? And then what's the other two?
The medians of the medians.
The medians of your medians, which is the Q1 and Q3. Those are your quartiles, right? It's like the 3rd quarter and the 1st quarter. Okay? So I need those numbers. Those are my 5-number summary. We're going to create a box and whisker plot. But in order to do that, you have to put them in order. I will tell you that the one that I make you do on the test has fewer numbers than this box does. So there's that. All right? So let's put these numbers in order. What's the smallest number?
29.
29. Okay? Then next,
Yeah.
33.
33.
Okay?
34.
I like to put these right below the numbers that are already there because it makes it easier to remember, to know how many numbers I have, right? Okay? So 33 is the next one. Then what?
34.
34 is there. Okay?
44.
Then 44 is the next one.
46.
44, 46,
47. 47.
47, 47. Am I going too fast?
Yeah.
No.
50. 53.
Hold on, let me get unfuzzy. 47, 47,
50,
50, okay?
53.
53.
54.
No, those are two 53s.
There's two 53s there, and where's the other 53?
There's one by the end.
That's the one that I got.
That's 63, probably. I don't know. Okay.
I only see one 53. 54. I see a 54 though. Okay, what else?
56.
56,
57,
57. Okay,
two 60s,
60, 60.
61,
Am I going too fast?
No.
60, 60. 61,
62.
62,
63.
63. Right there, yep, I see it in the middle. 63,
64,
64, 65. Am I going too fast?
no,
Nope.
67,
67,
70,
70,
74,
74,
75,
75,
76.
76,
78,
78,
80,
80,
83,
83, and 90, right? Okay. All right, we got them all. Was that too fast?
No.
No? Good? Colton, was that too fast? He's still writing. He's a lefty. Okay. All right, so there's all our data. How many numbers are there?
oh,
A lot. How many? We need to know that.
Okay.
28 numbers. 28 numbers. Okay, now we need to find these 5 things. What's the minimum? 29, the maximum? 90. Great. At least you should get those 2 right. Right? No excuses for those 2. All right. Now, which one do you find next? The middle, the median, right? Okay, I still have some of you guys, when you're doing this, cross off, cross off, cross off, cross off, cross off, cross off. Don't do that. Okay, if last resort, do that. If you can't remember how to do anything else, do that. If there are 28 numbers and I split them exactly into 2 equal pieces, there will be 14 numbers over here and 14 numbers over here, right? Separated by the 14th and 15th number, right? Okay, so count 14 numbers over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15 are between 60 and 61. What number is exactly between 60 and 61? 60.5 is the median. Okay, now I need to find the median of that. Okay, so I'm going to split it here and here. That's going to be my first 14 numbers. And then my second 14 numbers are here. Those are exactly 2 equal pieces, right? 2 chunks. Okay? There are 14 in this list and 14 in this list, and Erica said already, if there's 14 numbers and I separate those into 2 pieces, I have 7 and 7, right? So between the 7th and 8th number, 2, 4, 6, 7, 8, right there. 47 and 50. 48 and a half. That is my Q1, 48.5. Okay, over here, the same thing. 7th and 8th number. 2, 4, 6, 7. 67 and 70. No, not right. 2, 4, 6, 7. Right here. 70 and 74. I did that wrong. Which is 72, yeah. 7th and 8th number, 72. Okay, that one comes out nicely. So this is my 5-number summary, and then I'm going to put them on a box and whisker plot, yeah? Okay, so I'm going to draw my line down here. Oh my goodness. Wow. Let's do that. Okay. There's my number line. Okay. What do we want to go from? From what to what?
29 to 90.
29 to 90, but let's like pick some nice numbers. Like this morning or earlier we did 20 to 100. Okay, that's fine. Whatever. 20 to 100 is fine. Because what's exactly in the middle of 20 and 100? 60. Add them together. What's 20 plus 100? Divided by 2? 60. So exactly in the middle? 60. Okay? What's in the middle of 20 and 60? 40. What's in the middle of 60 and 100? I gave you the answer.
80.
80. Okay, and then each one of these between 20 and 40 is 30, 50, 70, 90. I have my number line, right?
Do we have to do Yes.
No, but just make sure it's evenly spaced. I don't care what numbers you go by, just make sure it's evenly spaced. Does it make sense? So if you went by fives or whatever you did, okay?
That'd be a long.
Yeah, that'd be a long ways. Or if you started at 10 or started at 0 and went to 100, I don't care. Or if you started at 30 and went to 90 and just went a little beyond 20, I don't care.
Keep going.
Okay.
Good.
29 is 29 is this dot right here. A little bit shy of 30. 90 is the last number, so we're going to put a dot right there, and I'm going to connect the two. My lines are really awful. 29 and 90. Those are my two numbers. It's just wait. It doesn't like my hand in there. Oh, come on. There we go. 29 and 90. All right, my middle is 60.5, so just about right there. Okay. My Q1 is 48.5, so about there. My Q2 is 72, so just about right there. And look at this beautiful, beautiful creature of a box and whisker plot. Check that out. What type of distribution is that? It's pretty symmetric. It's pretty well the same on both sides. That's awesome. Okay? So, if you do not label your box and whisker plot down here, what each one of those are, make sure you include that off to the side. If you do not have a label, I count it wrong. Right? So, if you don't have it labeled somewhere, that box means nothing to me. Okay? Good? All right, going to the top one. 27. We'll keep going backwards. What is the domain and range? So, we need those two things, D and R. Domain range. This function right here, what is the parent function of this graph? Y equals what?
Oh.
1 over x. He is the parent function of 1 over x, right? Those are the boomerang things. Okay, so for domain, domains are the x's, going left and right. Will he go to the right forever and ever and ever? Yes, because this arrow tells me that. Will he go to the left forever and ever and ever? This guy tells me that. He'll go this way. He'll go split both ways. Okay? So, domain should be all reals, right? Because he's going left and right forever. But
All real except for what?
he's not going to touch this dotted line right here, right? He doesn't pass through that. And that's at -1. So, it's all reals except x is not equal to -1, right? He won't touch that -1 value. He's going to go left and right forever, but he won't pass through. That's like a closed door. He can't go through there.
You just said all the numbers except for x is not equal.
Yes. Yeah.
I just put except -1.
Well, whatever. However you say it, I don't care. I'm not picky on the wording. Yeah. I get what you're saying. Yes.
There's your range.
Okay, range. What is range? Will he go up and down forever?
Yes.
Up forever, down forever? So it should be all reals, except you have this flat place where he's not going to cross. So y cannot be equal to 1, because it's 1 on the y-axis, yeah?
Yeah.
Okay, so however you word that, whatever you do, as long as you have something of that nature, that's fine. Okay, good?
Yeah.
All right. Oop, we're wrong page. 7. Let's start at 21, and we'll work down.
How far there is that?
7 to the 21 to the end. We stopped after we got this chunk done. We worked very, very slow. 6th period. So 21, y varies directly as x.
So y.
I will ask ask you one or the other of these. I will either ask for direct or indirect. Okay? So on the test, it might not be direct, it might be indirect instead. What does a direct variation look like?
Y times X.
Oh,
Yeah, y is
K
k times x.
times X, yeah. They're directly related. However, whatever happens to X happens to Y, right? If X goes up, then Y is going to go up, right?
Yep.
If they're indirect, meaning they're opposite relationship,
K divided by
Y equals K divided by X. So if X is going up, Y is actually going down. That's what an indirect would look like, okay? So Y varies directly as X. Stop there. That means we're looking at Y equals KX. That's what that tells me. Okay? Then it says Y equals 18 when X is 3. Stop there. If Y equals 18 when X equals 3, I'm going to plug stuff into this equation. Y is 18. X is 3. So what's K?
6.
If you divide by 3, Cody said it, K is 6. Okay? Then they want us to find Y when X was 5, right? Find Y when X is 5. So Y I don't know, so I'm going to leave it as Y. Okay? We have Y equals K times X, but what's K? Oh, 6. We already found it. What's X? 5. So Y is 30. There we go. Good, good? Yeah. All right. 22. We are simplifying. We have two things that are multiplied together. When do you keep flip-flip? When you're dividing. So I'm going to put like a little note maybe that says keep flip-flip, KFF, when dividing. So we're not going to keep flip-flip on this one, but maybe on the test we will. I don't know for sure. I don't remember. Okay. Are these things trapped?
No.
No. When are they trapped?
When you're adding.
When it's like an equation.
Yeah. When there is like a plus sign, right? Not necessarily when you're adding, because you could still be multiplying, but like this one, 23, that's trapped, right? Even though we're multiplying in between them, but we're still like x plus 3. So this one is trapped. So on 23, mark that it is trapped. Okay? You guys know what I mean by trapped, right? Okay. So on 22, we're going to start canceling some things out. Start with the numbers. Start with the numbers first. So we're looking at negative 16, 15, 27, and 8. Well, there's some things that we can reduce.
Can go to 1, 16, and 82.
This is 1 and negative 2. 16 and 8 becomes 1 and negative 2, yeah?
Yeah.
27 and 15, what will they make?
5 and 9.
Divide by 3, so 15 divided by 3 is 5. 27 divided by 3 is 9. Great. Okay? Now, at this point, my paper is too cluttered. I'm going to rewrite what I have, okay? I'm just going to simplify things. If you guys want to go ahead and keep simplifying, I don't care. But I'm going to do my write everything out clean step, okay? So negative 2 and 5 together will make negative 10. On the bottom, my number is 9, because 9 times 1, okay? Now, what do I have on the top for X, Y, Z stuff?
You can cancel your X.
I'm not going to cancel anything yet.
Oh.
If you want to do that, you
Y,
can.
Z squared.
X, Y, Z squared, right? On the bottom, you have?
Z X squared.
Yeah, I'm going to do X squared Z. It doesn't matter if you do ZX squared, whatever, okay? I write it out at this step so that I have everything clean slate and I don't get confused again, okay? Equals. Now I'm going to cancel my X's, Y's, and Z's if I can. This negative 10 and 9 are done. They're just chilling out, okay? Now X's, I have 1 on the top and 2 on the bottom. 1 X on the bottom, somebody said. I don't remember who it was. McLean, maybe? Bo? No, Bo. Okay, Y. I only have 1 Y on the top, so he just stays. Z, I have 2 on the top and 1 on the bottom. Z on the top. There you go. Okay? Alright, do not try to do too much at once. If you need to rewrite and make a step in between, that's great. Okay? 23, he is trapped. Okay, what are we going to do?
Break them down.
Break them down. X plus 3 and X minus 1 cannot break down, but the other two can. So, what can you multiply to get 1, but when you add them, give you negative 2?
X minus 1 is 1.
Minus 1 minus 1. X minus 1, X minus 1. Negative 1 times negative 1 is 1. Negative 1 minus 1 is negative 2. Okay? Now, what about this one? X squared plus 5x plus 6. 2 and 3. What combination of 2 and 3? Plus 2 plus 3. Okay? All right, I'm going to do something real quick. Up here. Just wait a second. Just wait a second. X squared plus 5x plus 6. We just did that guy. Okay?
Yeah.
He was x plus 2, x plus 3, right? Okay? Now, people get this confused all the time. These two, I'm just switching the 5s and the 6s around. But what does this one become? Multiply to get 5, add to get 6. Yes, you can. What is it?
Oh, 5 and 1.
5 and 1, okay? Make sure you know the difference between the two because one of them is a very, very different combination than the other, right? And I just switched the two numbers around. So when you're dealing with 5s and 6s, I have a lot of people that switch those around. It's not the same thing, okay? So we did that right down here. Now what? Cross out. What crosses out? X plus 3's cancel out. X minus 1's cancel out. Okay? Now, you can cross out this way. Are you guys watching me? Cross out this way. You can cross out this way. Can you cross out this way?
Yes.
Top on bottom. Yes, you can. Can you cross out over here? Top on bottom. Yes. As long as one of them is in the numerator and one of them is in the denominator, it doesn't matter whether they're on top of each other or diagonal. Doesn't matter. Okay? Good? All right. So, what is the answer? X minus 1 over x plus 2. Great. Okay? All right, 24. Uh-oh. Now we're adding, so what does that mean? More complicated stuff. What do you have to do? Find a common denominator. Exclamation point. Okay? All right, before we find a common denominator, we have to break this up. So, what are you multiplying to get -4, but when you add them, give you -3? X minus 4 and x plus 1. Woo! Let me zoom in. X minus 4, x plus 1, yeah? Okay, so in my two pieces, what do you want your denominator to be? I know I need x minus 4. I know I need an x plus 1. And I know I need an x minus 4. But I already have it, right? Okay? So, are we good so far? Okay, I have an x plus 3. And I do parentheses what he's missing, right? Okay, so the x up here has in the bottom, to start with, x minus 4, x plus 1. We want to get to x minus 4, x plus 1. So what is he missing? Nothing, so we take it times 1, right? Okay, the 3 on the bottom has an x minus 4. I want to get to x minus 4, x plus 1. So what is he missing? X plus 1. Okay, and now what? Okay, let's do the top. So x times 1 is just x, right? 3 times x plus 1. Make sure you distribute, right? Is 3x plus 3, right? That's what that top part is. The bottom part, don't try to multiply that back through, okay? Even though it's like technically this thing right here. Just leave it as x minus 4, x plus 1. Okay, and the top, simplify that if you can. 4x plus 3. Is it all coming back to you now? Nope. Okay. You can skip like 6 problems. What? You're gonna be good. All right. All right. Okay, good. All right, 25. So if you get 6, yeah, answer them all. If you get 6 wrong, then you're still good.
Then you get 100, right?
Yeah. All right, next. 25. What do you got? What are we going to do?
Find a common denominator.
Find a common denominator again because we're still adding, right? 2 is over
3.
1. Well, yeah. 2 over 1. Okay? So, my common denominator, I need something, something, something. Here's my fractioning thing. Okay, there's that. What is your common denominator going to be? You have 3x, or 3 times 3 and x and 1.
-3. Oh, I gotta make it 3x.
3x, 3x, 3x. All of them need to be 3x's, yeah? Okay? All right, so this top is 10, this top is 4, this top is 2. We need to multiply by what they need. What they need, what they need, what they need. So, this 10 right below him, he has a 3. What is we're trying to get to 3x. So what does he need? He needs an x, okay? Now, a quick way to check this, if you just look at 10x over 3x, the x's will cancel out, right? And I will get back to 10/3. That's exactly what we want, right? That's a quick way of checking to make sure that you multiply by the right thing. Okay, now 4. 4 below him had an x, he needs to be 3x. Oop, needs to be 3x. He needs a 3. Okay, so let's do the 2. This 2, he had a 1 below him, he needs to be 3x, so he needs a 3x, okay? Now what?
Now you can cross off your bottom parts and just go to town on the top.
Now, you cross off the bottom parts. Why are you allowed to cross off the bottom? Because of this guy. Because there is an equal sign, you can cross off the bottom parts, yeah? Okay, so the top, 10x equals 12 plus 6x. Subtract 6x. You guys are way too fast. 4x equals 12.
Divide by 4.
Divide by 4. X equals trace. Are we going too fast?
No, keep going.
Keep her going.
Wait a minute, just not writing fast enough. It's on.
No, it's like
Alright, next problem. Let's roll.
Okay. All right. 26. Simplify. What does this thing mean? Oh, I hate this. What does the 1/3 power mean? It means the cube root. I bet it can't.
What I just said.
That is what you just said. Because there's an x in there. Oh, darn. The cubic root. So the 1/3 power means the cubic root. So the cubic root, if we're looking at 8 and the cubic root of 8, that means what do you take times itself 3 times to get 8?
2.
2. The cubic root of 8 is 2. Okay? What do you take times itself 3 times to get x to the 3rd power? Just x, right? X times itself 3 times is x to the 3rd power. Okay? The cubic root of 27 means what can you take times itself 3 times to get 27? 3. So, 2x over 3. That is all. Boom. We win. Okay, good?
Yep.
Yeah?
Keep rolling.
All right. 18, 19, 20. Let's do that. This is logarithms. Ooh, logarithms. I love logs. It's like my favorite thing to teach. I do say that a lot. That's right. 20. Simplify. Okay, we got some time. Simplify e to the power of 5 ln 2. Blah, that looks like a lot of gibberish to me. I don't remember.
Your easy equal again, your easy equal like.
E is 2.71828818.
No, but like it's like you do the ln or something.
Okay? So, E
I'm hooking you up.
and ln. Whoop. ln. E and ln are inverses of each other, which means they undo one another. So if E and ln undo one another, they should just cross each other off, right? So like on number 20, E and ln should just cross each other off and make like 52, but that's not right. Okay? E and ln cross each other off only if they are directly like touching each other. So this 5 is in the middle. How can I move that 5? Now, Amelia just said, can't you bring it in the front? It is already in front of the log.
Could you put it behind the
Can you put it behind the log? So what will it look like behind the log? E ln 2 to the 5th power. Do you see that mess? There's a power and then a power again. You see that? The 5 can move to the back.
Wait, but 2 to the 5th power is what?
Okay, but E and ln cross out each other, so you just have 2 to the 5th power, which is
32.
32.
Let me double check that.
It is 32.
Yep.
What?
2 times 2 times 2 times 2 times 2. Okay? Good? So they only cancel out if they're touching. All right, 19. Oh my gosh. 19, there's a lot of log 6s there. Log 6, log 6, log 6. What? They will not cross out. Not 3 of them.
There's 2 of them. Wait, multiply, isn't it like 10 times, isn't it like 10x?
These 2 right here, what is separating those 2 logs on this side?
Addition.
Plus, which means
Multiply.
multiply in log world, right? Plus means multiply, okay? So what are we multiplying?
10 times x.
10 times x, right? Those 2 are added between them. So log base 6 of 10 times x equals log base 6 of
40.
40. And then what? Cross off the logs. Right? So 10x equals 40. So then divide by 10 and x is 4. Okay? This problem actually came from a test somewhere, I think at some point. 40, because 10 plus x is 40, right? 10 plus 30 is 40. That's not the right answer. Log world plus means multiply. Okay? Good? All right, plus means multiply. What does minus mean?
Divide.
Divide. Minus means divide. That's going to be on the back side here in just a minute. Okay? 18. You have, let me see if there's another one like this. Let's go to 15 first. Go to 15. We're going to skip around for here just a minute. We're going to do 15 and then we'll bump back to 18.
Wait, now don't we just raise the 4 to the, you multiply that by 3?
Yep, well, not 4 by 3. You multiply the 3x plus 7 by 3. All right, so on 15, your bases are 3 and 9. On 15, your bases are 3 and 9. Okay? I want those numbers to be the same number. Okay? How do you make 9 as a power of 3? Okay? This stays 3 to the 4x power, but 9 becomes 3 squared, right? And then that is to the 3x plus 7 power. Right? Yes?
Yeah.
Okay? All right, now the 3's cancel out. So I have 4x here equals, but the 2 needs to be multiplied through. 6x plus 14. Yeah?
Yeah.
So that 9 became 3 squared, and then we multiply it through. Are we confused?
No.
No? Subtract 6x. Negative 2x equals 14. And then divide by negative 2. X is negative 7. Whoop. That is all. Yeah? What?
No.
Oh, thank you. Good? Yes. Yep. That in your packet. Good, moving on?
We have
Oh, Colton Wayman.
no, we got it.
No, yeah, we have like 7
Let's do one
minutes.
more.
Let's do a couple.
We're going to go back and do 18.
Yeah, let's do 18 real fast. Let's do it.
Sure.
And then we have to do 17.
Okay. All right, go back to 18 because this is similar to the one that we just got done doing. 18. My bases are 8 and 30. Yeah? My bases are 8 and 30.
Oh, you have to do 4.
So I want to make those the same base. Okay? 2 to the, listen, 2 to the 3rd power is 8. How do I get 30?
You can't.
You can't. 2 to the 5th power is 32. It skips right over top of 30. So how do I do it if you can't
You don't
do the thing?
You put no solution.
Both of these, listen, both of these are exponential functions. How do you get rid of an exponent?
Oh, you have to do something with the
Okay, e's and ln's are inverses of each other. What's the inverse of an exponent?
something square.
I don't remember what is it.
A log. We log both sides, right? You're gonna fail this test. Okay.
Me?
So log. I'm talking about
Yeah.
TJ. He just said he's gonna fail. I need to start like deducting points when people say that. Like, yeah, I'll help you fail this test because I'll subtract like 10 points for every time you say that, right?
Now is that log? Is that 30 and those and that 8? Are they raised or is it?
They are raised. This is if there's no base on the log. What's the base? 10. So this is a base of 10 and base of 10. Okay, so
Band students, be sure to take your instruments home today. All library books need to be checked in by Friday unless other arrangements have been made with Andy. Grade 7 through 11, be sure to see the principal about your schedule for next year. 2022 city crew, you must turn in your $100 deposit and paperwork by Friday.
That's the test.
Friday.
Oh.
Sign up for summer wait. Start tomorrow morning at 7:45 in the business room. These are the word envelopes that are on the counter in the teacher's lounge. Those will be given out on the last day of school. Be sure to get the seniors done by Thursday morning.
oh, the room went off. Okay, ready? All right, so we log both sides. Okay, now what happens?
Do something with the M.
M plus 1, where does he go?
In front of.
In down in front. So M plus 1 times log of 8 equals log 30. Okay, and then what? I want to solve for M.
Subtract 1?
Nope, not yet.
What? Tony.
I don't know.
Divide log 8 over. Right? Just wait a second, Tony. Okay, divide by log 8. Yeah?
Yeah.
Okay, so M plus 1 equals, what is log 30 divided by log 8?
1.64.
1.64. Okay, and then what? Minus 1. So M equals 0.64. Yeah?
Yep, we done for that?
Capiche? Caposh. Great, that's it.
No.
Hey, come here.
Sure.
Whoa, Kate, Tony was first.